started with Stream1 presentations, if that's okay, Sarah.
Yeah, definitely go for it.
Yeah, and please go ahead and continue to enter feedback as you think about it, even throughout the presentations, because teams will be sharing their screens, so you can still watch that. So to start with, we have the Priceless DSO team, and they will be presenting everything that they've done so far. The jury members themselves will introduce themselves at the actual jury time at 5:15. Quickly for Stream1, I can go over who they are again for people who weren't in the introduction session. Okay, so anybody who's been part of Stream1 so far has met Dr. Etienne Geheim, who's been very active in the conversations, the Digital Innovation Officer at Ungi. We also have Luis Hernandez, who hasn't been a part of many of the sessions, but will be joining today for the jury session. I'm not sure if he's on this call yet. We have Dr. Sarah Hambridge, who you all know, obviously. She's our Grid Singularity product owner. And Jan Pellis, strategist and innovator at Stetten, who's also been very active in the debriefs and sessions. Yeah, hi, Jan. Okay, and in the actual jury session, we'll have the jury members say hi and introduce themselves. We'll stick to the time for now. Okay, so DSO team, have 25 minutes or so to discuss everything that's been done this weekend.
Check. Yeah, Robbo will share his screen.
So we have to find the right screen to share.
Great. Now, good morning, everybody. Welcome to the presentation of the Priceless DSOs. Yeah, we're going to take you along with the things we developed for this weekend and our results and our takeaways. But let's start. So we see, you see the energy transition going on. We get a lot of sun, wind on our grids, and that causes new grid loads, peak loads on our grid, and they cause us to invest more in the grids, and therefore the grid tariffs will increase. In the current grid fees in the Netherlands, we have a really how do we say it, fixed tariff system. So you have no variable fee. We have only you get the smallest bundle you can get as a consumer. It's limited by the fuses in your installation. So it's 3 times 25 amperes. You have 16 kilowatt on peak you can get, and you pay about €250 a year for it. And there's no flexible part in it. And nice thing we have in the Netherlands is that for the grid operators, so an Nexus or Steden, Liander has all, they each have the same tariff over the whole area. Now, what we want to achieve this weekend is look at ways where we can prevent the cost increase of our grid tariffs, and therefore we want to experiment with different flexible grid tariffs. These flexible grid tariffs should encourage the users to cause lower peaks on the network, but still, should limited have limited interference with the market. So it should be still able to trade only at moments when you maybe go way beyond the grid capacity, we should be able to protect our grid, and therefore the tariff system should support that. Further on, we want a time component coupled with the state of the grid in the grid tariff, so you have some coupling with the actual loading over the time with the grid, so you get a better reflection of the state of the grid in the tariffs instead of a fixed tariff. And it should be transparent for the users and also clear in advance, so they know what they can expect from the grid operator, and not that they at the end get a large bill. Okay. Then we go on to the tariff systems we developed for this weekend, and the expectations we had on what will be, what the impact will be, and the important KPIs. So we started this weekend with the main. In the forehand, we did already some kind of benchmark with the current tariff system, where there's no peak tariff on anything. So, but that was in forehand. And this weekend we run the base case with the fixed kilowatt-hour tariff, where we expected that it wouldn't limit the peak consumption because you just pay per kilowatt hours, and there's no increase in tariff if you go higher in the peak. So that wouldn't do anything. On that, we have the time of use model, or maybe you can zoom in a bit more. So where we look at the average loading over the week, and therefore we developed a tariff that reflects when the loading is high, you have a higher tariff, and if the loading of the grid is less over the day, you get a less tariff. And finally, we also looked at another tariff system. It's called the Aziz tariff model, and that is that's somehow instead of averaging over the day, it looks to the loads over the. We looked at the loads over the whole week and plotted it about how often it came by, and then we want to have a lower tariff in the low load settings, but if you go up higher in the bandwidth, then you get a further increasing tariff structure. So if you say you have about 10 times as high tariffs above than in the lowest point, and we expect that will really decrease the peak consumption in our grid, therefore hopefully also decreasing the grid fees and the overall system costs. And for us as a grid operator, the peak consumption is really the main KPI, because that is why we dimension our grids on. So that, in the short, as introduction to our weekend. Then we go to the results.
Yes, I will tell you a bit about the results we saw in the different simulations with the different teams. Mainly focusing indeed on the peak consumption. So it was very interesting to see how the different teams reacted to the different strategies. And we had some sort of base case or reference case, as Hans mentioned, in the what I call the vanilla experiment, where there were no grid fees. So there was no incentive to actually use your storage and the natural behavior of production and consumption in the community. And we saw in that case that the energy peak was 33.6 kilowatt hours in a PTU. So that is the stupid case, so to say. And then we had the three experiments. So the base case with a flat fee per kilowatt hour, that time of use case, and the Aziz model, as Hans explained. And for us, it's really nice to see that in each of the cases, using smart agents can actually bring the peak down. So you see that, for example, in the base case with the flat fee, that rebase had a peak of 27.68 kilowatt hours, which is lower than the original peak. However, you see that the other two teams, they had a higher peak. So and it's the same for the other two experiments, where some teams have a lower peak consumption and other teams have a higher peak. So the flexible fees and smart agents can bring the peaks down, but it's not necessarily the case. And sometimes it can even increase the peak by a lot, like we see in the Inavitas case in the Aziz experiment, which we'll have a look at closer later. So that was interesting to see the difference between the teams, the difference between the models, and also that it's not clear beforehand that the peaks will actually go down. We see similar differences between the teams and the experiments in the if we look at the total grid fees. So that is what the grid operator will earn in the week for this community. As we discussed earlier, in the base case, the grid fees were a bit high, so we earned like a lot. And then that was in the time of use in Aziz model, it's closer to the actual 270 euros that we expected to earn in that week. But also here we see a large difference between the different teams. And also, it's important to note that the lower peak doesn't necessarily mean a lower grid fee paid, because of course you can exploit a lower grid fee moment to actually increase the peak there, other than we expected. So that's what we see, for example, in the time of use model, where you see that Rebase doesn't have the lowest peak consumption, but it has the lowest grid fee costs. So that's interesting. And in the end, the grid fees are lowest in the Aziz model, which doesn't, again, it doesn't imply that the peaks are lowest. So that's something we have to look at if we are considering stuff like this. I prepared a simple plot to have a bit of a closer look at the things we saw in the experiments. So here you see the energy consumed on the y-axis and the time on the x-axis. So, and this is the vanilla community. So this is the top half is production, the bottom half is consumption. So you see that during the days there is some production from the solar panels, and on other time slots you have consumption by the other devices in the community. And what is interesting to see is to look, for example, at Rebase. Let's see. So if we add the flat fee experiment, you can see that the behavior is quite similar, because there's no incentive to actually lower the peaks. There's just an incentive to lower the trades. So you see stuff like this happening. The batteries, while the production is going up, the battery is filling up, and then the battery is full, and you go almost to the highest point of the peak again. And then the battery is emptying, and then you go back to the business as usual model. So that's interesting to see. So there is a limit in trading, but not in the peaks. If we, for example, add the time of use tariff, so the tariff structure is in the bottom, you see actually pretty similar behavior. So not that much is changing actually. So we expected the loads to shift more and more to the lower peak, the lower tariff time slots, but we don't actually see that happening that much, which is interesting to see, and also interesting to follow up on. So why is that? How can we make sure that this is happening more? And the same we see when we take the Aziz model with it. So we can. So here's the Aziz fee. So the Aziz model fee is personal for every community, because it's based on the actual consumption of the community in the past 4 time slots. And you again see that there's a very similar pattern that is followed here. So the grid fees don't seem to have that much influence on the trading as we had expected. However, there are some interesting things to look at. For example, if we look at we take the Inavitas time of use model, you see somewhat. Like at some timestamps, you see some shifting of the loads to lower price BTUs. So here we see the price goes up, and there are 2 consumption peaks just before and after the price, the high price moment. And it's also interesting, for example, if we look at so this is interesting, and if we expected this to happen more, and it would be interesting to see if the teams look at this closer, if they would exploit these low prices more and more, and even increase the peaks by doing that. If we take the Aziz model, there is a lot of interesting stuff happening. So the Aziz model it's a price that reacts on the things you're doing. So what we were afraid of, and what we see happening, not as much as we expected, but we see it a bit, is this behavior that you get a very high consumption peak, like 54, which is the highest we've seen. And because the Aziz model as it is implemented now, it is lagging a bit because it looks at the past 4 PTUs to determine the price for the next one. So you get a very high consumption peak at a relatively low price point. And then when the price goes up because of the high consumption peak, then the consumption shuts down and there's almost no trading. And then the price drops again, and then we see the peak start again. So that's what we see in this, the smart agents and an adaptive grid fee model. We see some sort of reaction of the agents to the actual price changes, which is interesting to see. But of course, this is not what we intended to happen. And if we look, we see the same happening. For example, if we look at Oli, in the Aziz model, you see some sort of strange behavior. So this is the time of use line, and we have the Aziz model line. So they're a bit different, but here we see some strange stuff happening. In the time of use model, the price go up, so the peaks go down. In the Aziz model, there's some sort of adaptive behavior where the price stays low and the consumption gets a bit more spiky. And you see that if you look at the whole picture again, if the Aziz model has inflicts a bit more spiky energy consumption in the way it is implemented here now. So that's interesting to see. And it's also interesting to see what the different Aziz tariffs are for each team. So we see most teams, they kept the max Aziz price below the 6 or 9 cents. And we see in the Navitas case that there is, they have 2 times where the Aziz price goes to 30 cents per kilowatt hour. And then they try to not trade on these PTUs and let the price drop again before they start trading again. So that's interesting behavior. So that's it, I think, for the short overview of the results we saw. So we saw some reaction to the grid fees, but not as much as we expected to see. And what is also very interesting to see is that even though the behavior of the agents is sort of similar in all 3 tariff models, the peaks are very, very a lot, and also the grid fees they earn is varying a lot between the teams and also between the experiments. So that's interesting to see and follow up on. We skate down to the takeaways.
Yeah, thanks, Robin.
Yeah,
I see that part of the text here moved away. I guess I didn't lock it, so it accidentally moved, but that's okay. But to follow up indeed, you can zoom in on the left part first. To summarize also, Robin's conclusion is indeed that we didn't see the large load shifts that we expected from the times with the high grid fees to the times with the lower grid fees. We also expect a little bit of gaming, but we didn't see it that much. We did see some reaction though, but it was mostly a little bit short term. But it would be really interesting for us also to see, because we think a part of the cause for this is that the agents didn't have that much time to optimize, because in between ticks and in between trades, there was a really short amount of time. In real life, you have agents that can take like 15 minutes for the next time slot to optimize their algorithm. And we think that maybe in that case, so we would like to see what will happen in the Canary network when they have more time. It's actually possible to react in a more comprehensive way to the grid feed and what is happening here. So we're curious to see what's going to happen in the canary case with that, and also with more training for the agents, if they will start optimizing more and more and actually at some point start exploiting the system a little bit and see what the effect in that case is. Another thing that Robin also mentions is that there's a lot of difference between the different agents in how much they pay in grid fees, and also a little bit on the peaks. And that's also an expectation that in the future we might want to try, because now the amount of data it was tested on was limited. But if they get more time to train and test, we expect that also to get a little bit closer together and to come together to a more optimal system. But that's also a future test that would be nice to see what actually happens in that case, and if we then see the results we expect more. To the right here, the text is gone, but another kind of takeaway we had were based also on the questions that D3A put for the different challenges. They initiated quite interesting discussions also, and we got a lot of input also for different kind of systems we could try to use in the future to optimize the tariff system. One of the most interesting ideas we got, and we have been thinking about that too a little bit, like some kind of hybrid system where you have these flexible grid fees that change in time, but at the same time you have like a capacity tariff or a bandwidth tariff for individual customers. And by combining these two, we think we might be able to counteract the gaming that could happen with optimal agents based on flexible fees, but still have an incentive in the system to actually lower your peaks. And in future developments, that would be nice to try to figure out how these systems would act. And what we've seen in this hackathon, at least, and also in the preparation, is that the platform of D3A, it's really easy to do a lot of experiments. And just see in a few hours what happens when you change the grid fee, put a different system in there, and by that way just come closer and closer to a new tariff system that's actually behaving in the way we want. I'm seeing one question of Irina now in the chat. She's asking if the grid fees are not so effective in managing the peaks because the earnings from trading outweigh the cost by the grid fee. It could be, but in the case here, I can go quickly to the results. We actually see that the grid fees are often 50% or 30% of the total cost. So if you go to this scenario, here you see that the total grid fees were 400 euros on a community bill of 800. So that's also something to look at. That's actually a quite high share. So even when the grid fees are a really high share in these scenarios, they're not that effective at this moment, at least, to reduce the peaks. But like I said, there are a lot of future ways to try to find out how we could actually come to a situation where they react more based on more time for optimization or a different tariff system. And this was a nice start. And we do see that actually the tariff systems do influence the behavior. So we see that the grid fees actually have kind of an impact, just not yet the impact we would expect or want them to have. But at some point we will get there if we do enough experiments, we guess. So these are my part for the main takeaways, and I'd like to give the word to Adam for
right. Some final closing words from the Priceless DSO team. It has been a long road to get here to Momentum, and we're quite excited to finally be here and fly around finally after I think it took us some days before we got it in there. But it has been a long and interesting preparation rounds together with the D3A and the good collaboration there. And we have tried to discussed the inputs back and forth, how to set up the experiments and so on. And it's been very, very interesting to be part of this preparational journey. That became slightly longer than expected, but now it's coming to an end, and we're feeling like, is this like now going to be the end of it, or what's happening now? Well, during the weekend we have had interesting discussions, and we got interesting inputs from many different people and team members and spectators and Jedis on ideas on how we could lower the peaks. And our main takeaway from all these experiments is that we see the D3 platform as a nice tool for running experiments on how the markets and trading agents would react to grid tariffs. And there are things that can be improved, like we have discussed earlier, like we maybe try to set the grid fee afterwards, or like reacting more on the physical trade, and instead of just the trades that are happening, but actually the physical flow of energy. But in general, we see this as a valuable tool, and we had some of us had yesterday a small tour together with the CTO of Stadin, and he was also impressed. And it's like, yeah, this way we can save in a lot of money on consultancies. So I think for the grid operators, this is I think this is has been a valuable journey.
Thanks, Adam, and the grid operator team. We have 3 minutes for questions. If anybody has any key points that they'd like to ask. All right. Thank you so much. I thought it was interesting how there are competing incentives for the grid operators want to reduce peaks, and the trading agents were really focusing on energy costs. So I think more investigation there to see how we can marry up those two incentives might be interesting. And I think we generated a ton of ideas of different things to try, and that we'll be developing our software to be able to try. So looking forward to continuing that partnership.
I'll give one compliment really quickly. I was really impressed by the quick turnaround on the analysis. I know you all were working on it yesterday, but I think the graph that Robin showed with each of the experiments compared directly, that was super interesting, and really great that we can already start to see some of these patterns in the results, and we can have this rapid prototyping. So nice job on that, and looking forward to analyzing the results even further.
Yeah, maybe shortly from my side as well. Thanks a lot to the grid operators. Was really cool. The cooperation here, and the goal was this prototyping and testing. To cut at least by 90%. And so I think I was roughly estimating what this study would have been cost by McKinsey, and I guess we have cut it by 90% now. So, and we still need to accelerate that a bit further. And so, count on us that we will definitely add more and more features to make this faster and faster and faster, that we can come faster to conclusions of new ideas. Yeah. Thanks a lot.
Yeah, thanks a lot to you all, and also the other participants for all the inputs and interesting ideas.
Perfect. Thanks, everybody. So now I will hand it off to Anna Turbovich, our COO, who you have seen active in the discussions and very active on Slack and behind the scenes in logistics. And she will introduce the judges and have them quickly introduce themselves.
Yes, it's time to really put the spotlight on our amazing jury, starting with Dr. Etienne Guéhan, who has been amazing and participating in all the sessions this weekend. Angie has taken on this brave step with us from the beginning, the leader of this challenge, of this particular stream. And Etienne himself has a background both in research and development, working with DERs for quite some time now. And he's also in various startups in our field. So really an expert in addition to being a decision maker. So Etienne, would you like to share with us what your expectations are from the teams in these final presentations from the jury point of view?
Yes, thank you. Expectations is, first of all, of course, key takeaways for the team and ways to, or ideas to improve forward. If you had more time, more simulation or direct connection with Canary networks, and especially how you see yourself interact with Engie in the future, selling us something. So a lot about business model ideas and lowest tariff possible, if you don't mind. But jokes apart, yes. I was quite impressed by the level of involvement, and I was also impressed by the fact that I could understand more or less what was the difference between the different teams, what they were focusing on, and therefore I look forward to understand even better. So I end up tonight with a clear idea of why one team succeeded better than other. And just saying that it's not necessarily the end result that counts, but the level of understanding of that result is more important to me. You see, if you haven't got a clue why you had this result, that's bad. But if you know what to improve and if you want to improve it, that's good.
Thank you for those words, Etienne. I will move to our partner from E.ON, Luis Hernandez. So E.ON has also been very active in this challenge for now over a year in this process. I see also Key Eichmann here with us. Hi, and other colleagues, Juan and others from E.ON. Welcome. So Luis is also, an expert in this field with a degree and a background in power engineering. But more importantly, he actually holds the title of the Innovation Lead for Energy Communities and Networks now, so very relevant for this challenge. Luis, I will let you share what you expect as a jury member from the teams.
Thank you, Anna. Thank you for inviting me to be part of this. I've been going through the different documents that have been produced in the last couple of days, and I've seen a lot of very interesting information. Honestly, the topic about variable tariffs is a very, very hard nut to crack. We've been working on it for a couple of years. It's not that easy. We know that the penetration of renewables and electrification in medium and low voltage is just starting, and it will definitely massively change the way things are being done as of today. And what I look forward today is to find out new ideas, new ways already based on results, on simulations that you have done during this week, on how this future could look like. Because it's a question that is very easy to ask, but it's an answer that is taking years to actually be able to answer, to find. So yeah, thanks for that, and looking forward to the results.
Thank you, Luis, and for everyone again from your team. I see Samuel here as well. I will now move to our priceless DSOs, and I have to say this humble name was self-declared, but I really think that we can all agree that they have been very valuable and priceless and amazing in this process. We've known Jan for a very long time. first through our work with the Energy Web Foundation and now working on these local electricity markets. Happy to hear that your team finds as one of the main conclusions that the D3A works wonderfully, and we hope to continue with you to use it in the future. Now, Jan, if you switch from this JEDI expert participating in the event now to a jury member, what do you expect from the teams?
Yeah, Anna, thank you for this very nice introduction. What to expect for the teams? Of course, I've seen them working and presenting already during the debriefs. I agree on what also was said before to have the teams show that they understand what their algorithms are doing is maybe as important as the real performance as we've seen. So I will be looking at that. And next to that, I would very much like if the teams could say something more on what they expect from the DSOs in the future, how DSOs can help and facilitate them in working in the energy system. So now we were there with our grid tariff. So they've already been experiencing our ideas, but I would also very much like to have their feedback, how we can build together on a robust system.
Okay, thank you for that, Jan. Finally, I'll turn to Dr. Sarah Haimbridge, who completed her PhD on this topic and is now implementing it, leading our product development team. Sarah, if you now try to switch from this role of someone who has been hosting essentially the event and supporting the teams, and you try to get into this position of a neutral jury member trying to pick a winner, what do you expect from them?
I think I've had the privilege to be able to listen to all the team's explanations and results so far. So I'm really curious how they can summarize their results and kind of make the case as to how their algorithm is working, how it can be improved, and sort of what they see as the next steps forward. So I'm looking forward to hear their key takeaways. And then I think, as Jan mentioned, maybe also their feedback in how the other stakeholders that are part of this hackathon can help them to further improve and for us to all further work together.
Thank you, Sarah. I also want to thank to all the JEDI who have been very active. I see Tim, I see Christoph, Mike Fell also joining us. Also some jury members from the second stream like Michael Hubner. So many thanks for joining today and having this intellectual brunch with us on a Sunday. I will now turn back to Colin, who will introduce the teams. And we have our final exciting moment of the final presentations of Stream 1.
Thanks so much. We really have had a ton of energetic discussions around a variety of topics today, this past weekend. So let's no more time to delay. Let's get right into it. So we'll start with Rebase as the first team to present, and we'll switch up the order.
Hello again. Can you hear me?
Yes.
This is Elias from Base. I will start the presentation and then my colleague Sebastian will finish it. 1 second to share my screen.
Oh, sorry. While you're getting ready there, I'll give a quick introduction of your team for you. So Rebase Energy, we've been working with them since, I guess, June when from the Chaos experiment, when the pre-session to this hackathon. Stockholm-based energy startup, and they're aiming to fight climate change by providing data and digital tools to empower the energy transformation. So they had a link on yesterday that they provided to their new website that they released yesterday. They have a data hub and a toolkit that allows people to find energy-related data, asset and market data in the unified API.
Thanks, Colin, for the presentation. So we'll start with presenting the results from the first experiments, where we ran a simplified version of our algorithm. And the reason for this is that we, till the end, till yesterday actually, we hadn't managed to run the optimization algorithm that we were scheduled to run from the beginning. But actually, even this simplified version produced quite well results. And the reason for this is that it was based on the reasoning of its implementation was based on the power flow in the system and how this is happening, starting from the house level, where the PV is balancing the load, and then going to the community level, and at the end, we're going to the grid. This algorithm doesn't look into the future, and this is also the reason why we didn't saw so much changes into the experiments 2 and 3, where we have dynamic tariffs. The base case was the case with the fixed tariffs, and our algorithm managed to achieve a score of 800, around 820 euros, while for the total bill of the community, while for the grid tariffs, we managed to reduce this to half of the total cost. Going to the time of use tariff system, we have a reduction by 20% in the total bill costs, and the grid fees were reduced to 35% of the total bill. And finally, for the Aziz tariff model, we managed to reduce the total bill 26% compared to the base case, while for the tariffs, the grid tariffs, this was up to 30%. What was more interesting is that actually yesterday, we managed to run the optimization algorithm that takes into account future evolution of the load and the PV generation and the grid tariffs. And we ran it for the optimization challenge. And the setting for this challenge was exactly as experiment 1. So we have a direct comparison with the results we got from the simple agent. And we saw that we could reduce the total community bill by 8.8% and the total grid fees by 50%. And actually, for the rest of the experiments, the time of use and WSCs, we expect to have even more reductions because it considers the future evolution of the load and the PV and the tariffs. And with this model, it's minimizing the total cost of the operation of the whole system. And having perfect information about the load and generation and the fees, we can achieve the minimum cost of operating the system. So actually, this agent can be used as a reference, as a performance index for the rest of the agents. And the closer that the score they can achieve compared to this, the better will be the agent. In these graphs, you see the comparison of the trading between the simple agent in experiment 1 and the optimization agent in the optimization challenge. And you see that we managed to reduce the peaks, both for selling and buying electricity from the grid. And for some sometimes we managed to get to reduce from around 28 kilowatt hours down to 22, and also for buying down from 24 down to 21, also for the rest of the peaks. What we are planning to do for the future is that since we didn't manage to run this optimization algorithm for the rest of the scenarios with the variable grid fees, would be to run this in these scenarios and see how it improves the performance. And another thing is that in a real trading setting, we will not have information about the future evolution of the load and the PV and the fees. In that case, we have to use our algorithm forecast of these quantities. So actually, we expect in a real setting that the algorithm, the score will be in between the score achieved by the simple agent and the best possible. So somewhere here. But this depends actually on the accuracy of the forecast. So the higher the accuracy, we are going to this level of the community bill. When the accuracy is decreasing, we expect that the total community bill will increase, and actually at some point we can go over the performance of the simple agent. So actually a good scenario to test would be what is the accuracy of the forecast we need in order to say that, okay, if we have an accuracy of that level or lower, go for the optimization algorithm, or if we have a lower performance, lower accuracy forecast, then use a simple agent. That is from me. I don't know if you have any questions.
Maybe I can present and then we can take the questions in the end. Is that right? Yes.
Oh, okay.
Thanks a lot. Okay, so let me see if I can. Yeah, maybe you can zoom in, or I can actually take over the screen. That's right. Okay. So now I should be able to see my screen. Is that correct? So I assume you can see my screen now.
No, we don't see it. No.
Okay. We'll try again. Can you see it now?
Yep.
Yes.
Oh, great. Okay. Thanks a lot, Elias, for the presentation regarding the smart agent and the results of the trading agent operations. So I will present a little bit more on the business models that we envision together with different stakeholders in the challenge. We already presented this, the setup in the grid singularity and the benefits of the energy communities, and how we see this going forward is actually building a community around optimizing and developing models for distributed energy resources. And we want to be a stakeholder there, enabling others with data and tools built on open source stack, so that we can have a stronger collaboration and sharing in the energy system and really transition to a fully sustainable energy system. So I actually built a couple of slides here for the 3 slides for the Odyssey challenge. I don't know, should we go into them now or should we wait until 15 o'clock to present those?
Now.
Now, okay. Basically, one of the challenges that we see, or the big challenges that we see in why AI and smart agents are not implemented at the scale as we want in the energy system and provide all the benefits that we can do, is because of 3 main things. It's because of lack of access to data. is because of lack of access to talent. So a lot of great data scientists are not in the energy space, which is unfortunate. They are in other areas like Google and Facebook and Amazon. And also the lack of collaboration. So big companies hoarding IP, not sharing with others. And this is something that we want to change. And we believe that the brightest mind of our generation should be thinking about climate change and how we can mitigate it, and not about how to make people click on ads. So our solution to this is the world's first community for energy management and optimization. And as Colin mentioned in the beginning, we are already developing tools and data, and we're in the market and selling these tools and data. And now we want to open source more and more of this in order to enable others to build on top of it. A little bit like Kaggle or Quantopian for energy, if you're familiar with those platforms. So right now, we have already launched our data. We have more than 200 terabytes of weather forecast data in our data hub that can be used for energy optimization. We have data from buildings, from solar plants, etc. that we're planning to open source. During this hackathon, we've been also developing the first version of the integration with the D3A platform for our open source toolkit. And we've been developing optimization models that Elias presented just before. And we're planning now to push this as an open source toolkit to a PyPy project. So it basically should be possible to just pip install these things, these toolkits. And the next step is to build a community, the collaboration platform. And here we see actually NG, for example, already collaborating with their La Haute-Born wind farm. And using a platform that's called Open Data Soft, if you're familiar with that. And we see ourselves as building on top of that, not only doing data that is local on Engie, but also cross-marrying that with our data, as well as building a platform for elaborating on AI algorithms, as well as equally important, the business models around it. So how can we use simulation engines like D3A platform to actually validate the financial and monetary benefits that you get out from these algorithms. Yes, okay, that's all for me. Thank you.
Thanks, Sebastian. So we have about 10 minutes for questions, and then the jury will be able to ask further questions during the jury round later, sponsored by Odyssey, where you'll have seen all the presentations and can ask more specific questions.
So any questions either regarding the optimization models or regarding the business models?
We have a question from Irena in the chat.
I have a question otherwise, or?
Yeah, please go ahead. Yeah.
How would this optimization model go ahead with the time of use? Would it like completely shift because it can forecast the tariffs, then shift all the loads to the low tariff moments? How would that impact the results? Do you have any feeling for that already, Elias, or?
Yes, for the time of use, it will be easy. We'll just, because they are fixed, so we can assign different tariff at different time spots. So the model will decide about how it will shift the load or the PV generation. For the Aziz model, it's a little bit more complicated because actually the price is a function of the peak of the generation, and this makes the model non-linear. So I have to think a little about how to include this directly, the Aziz modeling of the grid fees into the model. I'm not sure if you understand what I mean.
No, sure. I'm just curious if you had a feeling if you would expect to see a lot of higher peaks then.
I expect to see a lot of much more reaction to the prices compared to what we saw in the simple agent. Because the simple agent, as I said, it doesn't consider at all any future evolution of the prices and the loads and the fees. But it's questionable how this will be work in a real setting, because in real setting you make forecasts for the quantities. So if you have everything from the beginning, you know everything, then you can totally optimize. You know exactly what will be the optimal plan. But in reality, when you have forecasts, it may not performing so well. That's why I end my presentation saying that it will be interesting to see if how can this be performed in a rolling horizon.
Thanks for that question. We have one more in the chat from Irina. You can ask it here if you'd like, Irina, and introduce yourself beforehand so we know.
Yes, hi. So I'm working on optimization models, so that's why I was curious. You mentioned that when you were presenting that you optimized over I think the entire system were the words that you used. So I'm curious to know actually what is your objective function? Are you minimizing over the costs for the local market, for the entire community, or are you trying to maximize the self-sufficiency, or you're using a combination of several objective functions?
The objective function is to minimize the cost of the community.
Thanks.
Yeah, it's considering the feed-in tariff, which is a revenue for the PVs, the market maker price, which is the cost for buying the load from the grid, plus the grid fees. Actually, if you focus on, I don't know if you have access to the Miro board. I have posted the model 2 days ago on our debrief challenge one, experiment one debrief. So if you focus there, you can see the code, the model, how it is implemented.
Yes, thanks. I think I saw it, but of course it's a bit small letters. But thanks a lot.
Yeah, we'll make sure to upload it to GitHub as well and open source.
Yeah,
so you can have it there. Yeah.
Okay, thank you. Any more questions?
I have a question here, Luis from Eon, following up on Adam's question before. You mentioned that the Aziz model is the price is calculated as a function of the peak power. In which time window is that peak power calculated? Are you looking historically, average peak? So could you give me more insights about that?
I think it was 4 time steps. It's the DSOs could answer this question. What is the length of the window of the Aziz model?
Yeah, 4 times what's the 4 previous, the average of the 4 previous.
Yeah. So actually in the optimization model.
So 4, 5.
Yeah, please.
I wanted to ask 4 50-minute time steps, historical? Okay.
Yeah, and I want just to add, to say that if we want to include this function, this cost, because it's not fixed cost in the model, it's a function of the power, then because we multiply with the power, then it becomes the model nonlinear. And this is how we have to figure out how to solve it.
Okay.
And I believe the DSO team, when designing the Aziz model specifically for these experiments, had played around with different time windows and plan to going forward as well for that rolling average.
Yeah, that's correct. And the Aziz model, I think, as we implemented it here, is an approximation of what we, in the ideal situation, would do. So, and the window was a bit to flatten out the irregularities and the gaming opportunities.
Okay, thank you so much, Rebase. We will now move.
Thank you, too.
Yeah, thank you. We will now move to the Oli team. So the Oli team is a team with 3 companies. So we actually have representatives from Oli Systems, Siemens, and from the machine learning company InSignal AI. So we've been working closely with them not only on the challenges, but also on getting the first Canary network up and running. So Felix, the team captain of Oli Systems, of the Oli team, we are seeing the live data from his house in our Canary network as we speak. Can check in on when he makes tea. So go ahead, Oli.
Thank you, Colin. I think, Jan, you now have to share your screen.
Yes, I'm going to.
All right, while this is happening, just a few words about our approach here. So we're going to try to explain our approach in our last 8 months or so with the help of a timeline, explaining in some level of detail what we did, where we failed, where we started over, and how we ended up. And Jan will lead through that timeline before Mukund will go in more detail into the agent itself before I will close the presentation. So, Jan, are you ready?
Yes, I am. You can see my screen clearly, I hope.
Jan just wanted, can you hide the cursors?
Yes, of course. Yeah. Okay. So I want to briefly give you a tour. I want to take you with us in our journey from the start of this whole journey until now. And I want to emphasize on the fact that at the start of this journey, I was standing alone in the school where the whole first event of Odyssey was. And I signed up at a online board where you could make a team. And then I got an email from Mukund, and he asked me to join his team. And I also had a colleague who wanted to participate in the team. And then we started teaming up and started to explore what this challenge was all about and how to go further in that. And Mukund and the whole Oli Systems team already had some experience, so that was quite a good start for me. And then we get along our journey. First thing we did was, of course, getting to know the D3A tool, getting to know the D3A API, which shifted sometimes, was restructured sometimes. So that was a first thing to learn. And then we started really brainstorming on what to do, how to structure this agent, and where to start with choosing a specific machine learning algorithm to apply to this challenge questions. And that all, of course, started with reading a lot of papers and also using the research work of our teammates Mukund and Godwin to start developing an agent. And this agent was built, as we already introduced you to the Q-learning method. And this Q-learning method is based on the fact that an agent learns step by step to perform actions in an environment and recognizes the state he is in based on some parameters of that environment, and then gets a reward every time he tries a specific action, and then improves his or her actions in that environment. And where we started with was, okay, well, we have this environment and we have this agent. How is this agent going to define the state that he or she is in? And we did that with defining these 3 parameters. These were also already introduced to you in previous presentations, but I will give a short recap again. So we have these 3 parameters: the PV parameter that tells something about the PV energy that is available as compared to the maximum PV that could be available for your household, and the traded volume parameter that tells something about how much energy is traded in the energy market at that time, or an average of that time. And we have the market price parameter that tells something about how high the market price is at that moment. And based on these three parameters, the agent will define a state and will, based on that state, define the action to take, define the height of the bids that he or she is going to place in the energy market. So this was our starting point, and we started to build an agent based on that. And first we started with building an agent that didn't learn, but just based on the state, did a specific action without improving. And yeah, we built that. And you must know that at this point, of course, the whole COVID situation started. And this was all done digital. We only had digital contact until then. So this was also quite part of our journey to do it that way. And we went testing, evaluating, of course, and testing back again and evaluating back again. And then the chaos experiment happened. And we learned about what could work for our agent and what could not. We also saw the approaches of the other teams, and sometimes they were already quite far ahead. So that inspired us to move further and take more time to tackle this challenge. Then we finally got to the point that we moved from the weighted from the non-weighted Q table, so the Q table with the specific actions, to a real Q learning method, so a table that got better every time an action was performed. And we also improved our agent design, because when we learned that when we had these Q tables available, we also had to find a really good way to link the Q tables to the different devices or households. We had to choose how to do that. And then we came up with this modular design just to go briefly through it again, because I already told something about it in previous presentations as well. It tells something about how we look at the household and when which Q table is used. In general, a Q table is used for every device, and based on the situation that the household is in, so whether it's a net consumer, whether it's a net producer, or whether the battery sees an opportunity to trade, one of the Q tables of the household, or sometimes also two of the Q tables when the battery is involved, is used to define a bidding strategy. And then we saw the Odyssey Hackathon coming very quickly coming to our door, and we decided to meet again, to meet in person physically, to do a final sprint to the end result. And we visited Stuttgart. Me and my colleague from the Netherlands went to Stuttgart to do this final sprint. That was a big relief to see the OLI team in person. And of course, we did everything following the safety regulations, except for one of the safety regulations, and that was the speed limit in Germany. Unfortunately, we got a speed ticket. And when being there, we also started to really focus on our learning strategy for the agent, because the Q table was now finished, and now we had to find a structured approach to let the agent learn how to behave on these dynamic energy markets. And then we started to think of, well, what happens if the energy market is really changing? So maybe slightly changing because neighborhoods are added to the community, or maybe large buildings are added to the community. And then we started to think of making the Q table more fluid, and we did that by giving the state table the opportunity to redefine the boundaries between the different states, And I also already explained that in the previous presentation, but so what happens is all these different state boundaries are redefined based on historical data and will slightly move with the changing situation that is going on. So what is the advantage of doing this? The learnings on the previous defined states is still somewhat included in the new state divisions. And this learning will slightly be redefined based on these new state boxes. And another thing we came up with is, well, what do we do if really we really see the agent that the agent is really doing worse in a specific scenario? Then the agent should know how to when to relearn, and we need to define a specific trigger for that. And then after a burrito lunch in Stuttgart, the burrito factor was born, and the burrito factor tells something about the performance of the household within the community, and it compares the costs that a household makes on this energy bill compared to other community members. An estimation of what other community members do. And if that is really worse than the other community members, then the burrito factor triggers the agent to relearn again. And we used both of these things to define our learning strategy. And that learning strategy was then used in the last steps towards the Odyssey Momentum Hackathon to train the agent. And then the Odyssey Momentum Hackathon started, of course, all digital. Here you see my personal setup and, of course, the very cool online environment where we all were part of. And Mukund will now tell you more about what happened at the Odyssey Momentum Hackathon.
Thank you, Jan. If you could follow me now. Perfect. Okay. So the Odyssey Momentum started. We were all excited to test our agent, and until the last day, we had some issues, but thankfully nothing went wrong. And the first issue, then after the hackathon started, we saw that the battery was acting a bit strange. In our system, the way we designed it, it was supposed to discharge completely during the night. And the way we were deciding on this was to look at the historical data to understand which are the most expensive time slots, and use those time slots for the battery to kick in and then fulfill the load. And finally, yesterday, we realized that the only thing we were missing was we were only considering the load and not the PV as well, which would also act up in positions where to fulfill the load. So that's something we try to optimize in our optimization challenge, and the results improve, but we also realized there might be more factors that might be affecting it. On the other hand, what we also saw was that our strategy with terms of the grid feed change was actually working on the rudimentary basis. As you can see in the first challenge with our range, we saw that the highest peak was occurring at 8:30. And as you go from challenge 2 to challenge 3, we saw in challenge 3 that our net energy was actually reduced by almost 12 kilowatt hours. So that means the battery actually kicked in with the change in grid fee and were able to save the day and reduce the peak. But unfortunately, that was also causing the future peaks, which in some cases were higher than the initial ones. So this is something we realize we need to take into account into managing how the battery discharges, not just on the reactionary basis. But other key takeaways that we had are that our current approach of combining the PV and the load as a single unit with net demand is actually working as expected and makes a lot of sense. And the burrito factor, in terms of how it increases the learning factor aspect of the queued learning strategy, also makes a lot of sense. But with the battery and with the flexibility options, there are a lot of questions open. And we also realize a lot of different things that we might need to make a two-tier approach, which is based on the price-based approach, where you get the signals for increasing and decreasing your battery output, and also based on the volume. Now, this could be ultimately done based on the customer preferences also. If the customer thinks that they want to use the battery to fulfill their own needs, then a price signal is enough. But if you actually want to contribute to the community and help to balance the grid, then a volume-based approach might be better, where you can call in, say, okay, the total volume being traded on the market is increasing by a lot, so it might be a good idea for your battery to kick in and save the day. And yeah, with that, I would give it back to Felix to conclude. Thank you.
Thank you, Mukund. Can you please now follow me, Jan? Perfect, thanks so much. So I just want to quickly close now this presentation by giving you a short takeaway from our side. So maybe a few things about our lessons learned throughout this hackathon. We found out that this open exchange of ideas is something really important, and you do not want to get stuck in your bubble, especially over long periods of time, like these 8 months since March or April. Really talk to people that maybe don't agree with your ideas, talk to people, introduce them to your ideas, get some feedback from the outside so you don't get stuck and get that important injection of ideas from the outside. Of course, the whole remote work, digital work topic is all around us right now due to COVID. And it was challenging for us to get this going because we didn't really know each other. We were communicating via mail in the beginning. And slowly but surely, we went through a process where we used Slack on a daily basis and GitHub management solutions and some Jira, and just got things rolling for us. But really, only after meeting up in Stuttgart, we really had the system at 100%, I would say. Also, it's really important to know and understand that many things in the energy sector appear much larger than they are from far away. The closer you get, the smaller some things become. And that's really counterintuitive to how our visual world outside there works. And maybe a perspective from a team captain here, it's more a ceremonial position, of course, but it's really interesting how you can influence things with some very light macromanagement tools to keep things in place, to set up tools. So I was mostly acting as a scrum master, I would say, and let the team themselves organize and set the tasks. All right, about the next steps going in the future at the finish line, basically. So just here, the main takeaway would be that our Q-learning approach is something that can be easily customized to the data available, which might differ a lot in a real-life scenario. The same is also for the reward system, which can be customized depending on the agent requirements. We also did a lot of experimenting with the whole value chain, from the devices to the visualization, in between the agent, of course. And we got a lot of questions now in our mind, have been able to answer some of those as well. And maybe we can also set some requirements going forward. And also the network that we have built up. We have nice network inside the team, but also outside of the team. We talk to many different people, and we are ready to go and continue here. But maybe the most important thing is that we actually believe we have now a right set of questions that we can take out of this hackathon and continue answering and continue working on, and hopefully then also to come up with specific requirements to build this real life LEM without any simulation components anymore, but real life people, real life devices, and real life apps and real life kilowatt hours that are being traded. Thank you so much for listening to our presentation. That's pretty much it. And now the audit team is looking forward to answer your questions. Thank you.
Thanks, Felix. If you have a question, please introduce yourself quickly so we know who it's coming from. One thing I didn't hear you talk too much about was the Canary network and how it was running at the hackathon. Any major outcomes from that, and what you think that could look like going forward?
It worked for the most part. I was a bit surprised about that, to be honest. There are many challenges out there if you run a real-life network, especially with devices that are behind customer routers and 3G or 4G or even edge connections. A lot of things that can go wrong, and understanding what can go wrong and to what extent things could influence the market and how to build resilience against that. That's really crucial. Because usually during simulations, you always assume that everything is fine, the communication is going well, there are no missing values, the values are not corrupted, and so on and so on. And it's very crucial to build in this resilience against these situations, because otherwise the UX at the end will suffer a lot. And you don't want your user to suffer, of course, because of your failings in building resilience.
I have questions to Jan. This is John from Inevitos. So one thing is that we have a similar algorithm in terms of deciding, depending on the house to become the net consumer or net producer. You are deciding on the strategy of the battery. We couldn't figure out that our battery was not charging, and Mukund said that yours was not discharging. So that would be something that we can collaborate in the future to check it out. Probably it's because we cannot introduce the algorithm into the strategy very well. Do you have any comments on that? Could you figure out what was the reason you couldn't discharge fully?
Maybe I can jump in over here. The battery part, discharging, because we were using historical data to understand which time steps in the day would make sense or would be likely to be used for the battery discharge, we used the historical data again. So it is very much possible that going forward, the load was not exactly how we predicted, and it was much less. So we did not judge this completely because of that. Or initially, as I said, that the PV might have also kicked in, and we were only considering the PV initially. So because of that, also there is an interface which we were not considering. But I think there might be some other factors that could influence it also. But that's again something I'm looking forward to working on in the near future.
Oh yeah, this question was for you, Mukund, indeed, but the Brutto factor, because Jan has introduced it. So did you use it in this challenge actually? Because we were managing the whole community. It would be and can you also show the Brutto factor results maybe in the future?
Yeah, are you taking it or? Okay. Yeah, we did consider it, and we unfortunately we were not able to plot the graphs to show it to you, but we did see how it was changing throughout the day, and because we were taking it 3 or 4 times a day, and then how it was changing on the long term. So we saw more changes at the start because the strategy was developing itself, and we saw similar values stay as by the 6th day and the 7th day. So this was something we did not anticipate to happen, but it was good to see that it was actually working the way it was supposed to.
Great, thank you for the answers.
We have a question in the chat from Thomas. Would you like to ask it, Thomas, or I can?
Yes, hello. You could ask, but well, I'm speaking, so maybe I could ask it. So you were talking about the burrito factor, right? So it could happen also that, I mean, due to some, maybe your model is a little bit worse than the average one. Mm-hmm. I mean, the fundamental model, the states you've chosen and everything. So it could happen that the burrito factor is constantly positive, So even though your agents maybe found the best possible strategy, it would trigger a relearning process which may decay performance. So that's maybe something that you can.
What I didn't tell precisely is that the derivative of the Pareto factor is taken. So if a household is always performing worse than another household in the community, then that is not a problem. But if it's going to perform even worse, then it basically tells that another household is taking advantage of your position because another household is doing better. So we're taking the derivative, so not the actual Pareto factor itself.
Just to clarify that, you're comparing to your own performance always. So that, and you're comparing to the community's performance compared to your own performance, and you always look at the last time you were comparing, okay, how it was. So it removes any, at least that's what we realized, that it should remove any external factors that could influence it. Does that answer your question?
Yeah, partly. I think probably still need to think a bit about it. It could possibly be what's it called, exploitable by some adversarial. I mean, it's good that you're thinking about it at least, and that you have a potential solution. But I think this is something important to think about, since it's an important part of the process in your algorithm.
Yeah, thank you for your input.
Yeah, thank you for your answer.
So this is Stream1 is definitely the more technical stream. We have a lot of input about how we can reduce the cost and optimize the system. And at 1 o'clock, we'll have the Stream2 teams be presenting about what we can actually do with that benefit. So we had some discussion in the chat with Kirsten about, can you use that savings benefit to then reinvest in more sustainable resources for your community, for example? So just we're thinking very mathematically here, but it does extend into how do we then build this social system that works well. Okay, any other questions before we move to the last team of Stream1?
Maybe one last remark from my side concerning the Canary network. So in the Canary network, we also have smart meter gateways included, which basically are the German certified way of getting quarter-hourly production and consumption data from households. So all the teams have been able to actually use data, partially or that, which can be used for billing purposes later on. So the main question about how to get real life values from devices, how to make also real-time billing is pretty much answered by using those smart meter gateways here in Germany. I'm not entirely sure about other countries here about their solutions, but that major pain point is pretty much solved.
Fantastic. Thanks, Oli. So now we'll move to the final team presentation, and that's the Inavitas team based in Turkey. And so they describe themselves as a team composed of professionals working in the digitalization of energy distribution for more than 8 years on average. So they believe that local energy markets will bring efficiency to manage smart devices such as distributed energy resources and energy storage, changing how we produce and consume energy. And we've also been talking with the Inavitas team over the past months about how we can bring local energy markets into the Turkish market, and learning a lot about the Turkish regulation and the current state of affairs.
Thank you for the introduction. Yeah, so the Turkey is also, after the liberalization, is moving into the energy transition, and the distributed energy resources are also increasing, together with the problems between the investors and also the distribution companies. And in Inavitas, Mr. Erman, who is the partner of the company, will introduce you the company and how they try to solve this problem in Turkey.
Okay, hi all.
John, maybe we can share the mirror. Okay. Okay, first of all, thanks for this hackathon. It's really great to be a part of this hackathon. And yeah, Innovitas is a company in energy digitalization more than 8 years based in Turkey. So as we said, we have started in 2008 and 2012. So we have 2 different domains there and started with the utilities. So what is the main thing that we are working is started with before the unbundling of electricity networks, which is where the utilities, transmission, distribution, and retails are bundled. And then we were working on more on the power quality. And then after the unbundling, after 2010, where now we are working with 21 DSOs in Turkey. You know that Turkey is a huge country with lots of actual distribution system operators inside, and we are working nearly with all of them. And we, as I said, we have started with power quality improvement and the monitoring parts. So because as you know, the main focus is always energy management and the efficiency in the energy. So during that time, basically when you are talking about the efficiency of energy the efficiency is generally improving the power quality, or efficiency is in the home and the business side is just only turn off the lights. So it was just only the saving. And actually we used our energy management systems, including our own low cost IoT devices. So we have been using IoT devices everywhere in the substation automation, secondary substation automation. So there is a completely new type of design. And then we started with working with the renewables, integrating renewables into distribution system operators and businesses and the home. So now, as I said, we are monitoring more than 20,000 points in distribution system, 2,000 wind and the solar power plant, more than 2,000, and more than now it is more than 6,000 points in the businesses, 6,000 different units. So we are trying to actually increase the efficiency here. The main way of increasing the efficiency is coming from, optimization of the grid, optimization of the consumption, and the managing of consumption and the grids. And why we are here in this hackathon, it's really excited for us to be a part of this hackathon because, as I said, we are coming from the utility domain. We were working, we started in the utility domain with the power quality improvements and the energy management, which is the conventional energy management. But now we are focusing more on the businesses and the homes, where we want to actually manage the energy. And it is, we can easily say that it is the total management of energy starting from transmission to the end users. So that is the main motivation of us to focus on energy management. So we are trying to actually improve and optimize the energy management usage for businesses and the houses and even the communities. So community grid is very, very important, actually, key words for us, which we will be very active there. And now, other than Turkey, we are working in Australia, which is a totally different country, different networks, and there we are focusing on batteries, EVs, and the management of storage, consumption, production from
again, as I said, from the utilities to the end users. So that is the main thing, that why we are here and what we are doing. And now I want to leave the stage to the real heroes in our team, and they have been doing a lot in the last 3 days, and we will give some feedbacks about what we did and what we got from this hackathon.
Thank you very much, Mr. Erman. Now, I continue a little bit on decentralized autonomous area agent. As Mr. Erman explained, Innovita's goal was mainly to help the end users manage their consumption, give them efficiency, and also let them control their bills. But we also know that on the other hand, the later technologies could enable us to communicate between those end users and create a self-sufficient community between each other. So this visual I have taken from EnergyWeb. As you know or not, EnergyWeb is a blockchain network of companies that are actually innovating and using blockchain for their decentralized apps for the end users and for the energy transition. So here actually during this hackathon we have discussed mainly on regulatory and social objectives. And meanwhile, our team was focusing on shaping the sector and focusing on the risks and threats and how we can build the model on D3A and to overcome these issues on the sector. So Grid Singularity in here is enabling a new community that can use their software and implement in their own environments and test further. And this open innovation we will benefit all of us and further develop. So now I will give the stage to our data scientist, Rabia Sheiman. She will explain what we are taking away with us from this hackathon. But before that, I actually would like to show very short and talk about our algorithm, where we found two main mistakes. One of them was pointed by Tim, that we were focusing on the self-sufficiency. So we were in between focusing on self-sufficiency and minimizing cost, but we should mainly focus on cost minimization for the future. And on here, our house is net importer, our battery is failing, and we need to find out the reason for that and test further. And if it starts to work, then we would also get better results in the future. So go ahead, Rabia.
Hi everyone, I'm Rabia from Innovitas, and I will explain the graphs here. You know that the main purpose of these experiments is shifting the surplus energy from PV to the storage for consuming at the peak hours. With this, we can decrease the cost, we can make profit. We should store the energy on noon, we should consume on the evening. And as Can Bey mentioned before, in this hackathon, we have conditional-based strategy. We were trying to find the answer of the question, is the house is net importer or net exporter? according to this, we increase or decrease our business and offers linearly. So we were trying to shift our surplus energy to the batteries, but at some points we couldn't be successful, especially before our storage strategy. We couldn't use our storage efficiently. We couldn't charge it actually. Now let's look at the graphs. There are 3 columns. The first column shows the total cost of the 3 experiments actually. And green line is the load cost. When you subtract the PV profit from load costs, orange line is coming. You can see that without storage, PV is not enough to decrease the cost at peak hours. But could you please go down experiment 2 and 3? And when the grid fee changed, we made more trading with lower cost. You can understand from experiment 3 screen line, but because our storage strategy is not good enough for taking lower costs, we couldn't charge our battery fully for the night. If we could do this, we can make lower cost, of course. And let's check the other graphs. And we have 3 houses here. We selected 3 houses from all houses. One of them has load, PV, and the storage, house 23. One of them has load and PV. It doesn't have storage. You can see that it can store the energy for the peak hours because it doesn't have storage. We can understand from these 2 houses, storage is necessary if there is a PV on the roof. What about if the house has only load? Let's check the 15, house 15. The result is changing experiment to experiment. If the fees is changing, it can decrease the total cost of the load. It has no chance except buying the energy from the market, but it can create better bids for buying cheaper energy like that. We can understand from experiment 2 and 3. And all in all, I want to say again, our storage strategy didn't work as we wanted. We want to work on our storage strategy as future steps. We want to charge our batteries fully, we hope. Now, Mr. John will continue with what is next.
Yeah, and also about the optimization problem. So that was very nice from Sarah and Colin to give us a one last chance, because meanwhile we were still trying to change the strategy and test it. And I added here 2 graphs, and in the morning debrief, Sarah has also mentioned that our results were slightly better. Here we changed the minimum price setting, and then in the first one you see that our minimum price setting was almost not changing, but in the second one it's responding a bit better, but not enough. And the battery strategy was still not behaving the way we wanted to, but our peaks were managed better, as Sarah has shown in the morning brief. So in here we have looked at things from the investor point of view. How would you get your return of investment for battery and solar PVs? And we would also like to look at the problem from the DSO point of view, because our customers, Innovitas customers, are mainly DSOs, and we can show them something more interesting. So what is next? So here, long story short, in Turkey we support renewable energy by feed-in tariffs, and lately we have announced self-consumption model. So the DER smaller than 1 megawatt installed capacity can only be self-consumption. It can only get self-consumption model, which means we are settling the consumption and the generation of the solar PV in a monthly basis, and then you pay the net of the bill. But this is not attracting new investors due to two reasons. One of them is that the Turkish lira depreciates. So Turkish lira is depreciating, which doesn't affect the electricity prices directly because Turkey has increased its local resources of the energy. But on the other hand, the PV initial investments in US dollar. Another thing is here that the grid fees on self-consumption model is also not attractive for the investors. They are much more higher, so if you generate more than you consume, if you generate equal to what you consume, you still need to pay your grid fees, which are quite high compared to those who are not using self-consumption model. So DSOs were also skeptical about DRs in the beginning. So the transition is not easy, but now they're noticing that it is giving them the power to flexible grid, but how they can manage it. So they are keen on learning. And somehow worried about this new EV that they are saying that they're going to introduce very cheap into the market. And if so many people start buying it, that might affect the grid in the near future. So we would like, as Innovitas, together with Grid Singularity, test D3A in Turkey in real life. This canary network was an eye-opener for us as well. If we can get the support from our customers, we can also connect some Turkish load data, PV data to Grid Singularity and work in a Turkish case. One another thing that we are also discussing, that we can use D3A hackathons in Turkey using this platform together with DSO partnerships in Turkey. We can build teams in Turkish universities and find out talents there. That's going to improve our strategy in the future. So that's all from our side.
Thank you, John and the Innovitas team. Any questions?
Maybe questions about the self-consumption model and compare it to your own countries. I know that it also exists in Europe. What are your feelings about it? And
well, I'm sure we'll. Etienne, did you have something?
Sorry, I don't know if I'm allowed to answer that.
Oh, for sure, yeah.
Yeah. Just saying that in France, it's about the only use case that is starting to be profitable. But it depends a lot on grid fees and taxes, where there is a regulatory sandbox and specific grid fees. It works, but we see it coming better and better with the lowering cost of batteries. And that's why we think the only initial use case for an energy community is collective self-consumption as a first use case, because it's just an extension of what you can do on a simple home. And of course, a simple home use case works best if you have heavy equipment or electric heating, heat pumps and things like that. So it's not all the houses that can be profitable. And of course, it works best in the south of France than in the north, because there's more PV.
We were thinking about a situation where we have, for example, a large supermarket or one business which can invest on batteries and solar panels that is available, that can have available capacity to build a PV, larger PV on their rooftop. And as you mentioned, build their community that this large source of capacity can supply to the community with a better price. That was one of the use cases that we were trying to show. And using the 3A platform, that would be possible.
Yeah, you might find that the cost of installation becomes a very, very high element. And it's difficult to streamline because there are no standard roof situations. You end up with studying every time a case-by-case installation. It's difficult to standardize and say you have such surface of roof and we send you, or we send to the local installer that PV kit. No, in fact, every supermarket roof is different, with different installation of ventilations and other equipment. So it's a difficult use case to make profit from.
John, maybe I can add one more thing about the self-consumption here. Especially in Turkey or in some other countries, the outages on SAIDI and SAIFI indexes are really high, which makes the usage of diesel generators and the big UPS is a must in most of the businesses. So in the battery case, in this use case, you will actually get rid of this kind of cost too in the future. So here we are trying to actually manage we are just only thinking the first installation cost of battery and the PV, but yes, when you have the first installation cost of battery, it will decrease the cost of diesel generators and the other things like the UPSs. So I'm thinking that it's very soon, yes, because of the depreciation of Turkish lira, we have some problems in the grid prices, but when we actually get rid of this kind of cost in the future, the battery will be one of the main players in this kind of countries too, because of this kind of outage problems and that kind of things. So I think we can maybe work more on that part to think about, and that in this kind of countries, self-sufficiency is very, very critical because of this problem.
Great, thanks for the discussion, everybody. And wonderful presentations. To close it out, we're going to pass it over to Ed, our CEO.
Yeah, thanks everyone. A huge kudos from my side to the teams and to the grid operators. It was, you did so much, so much preparation and for us, the biggest, as EnergySingularity, it was of immense help to understand, to validate the model, the market design, and help really from grid operator perspective, from aggregator perspective, and so forth. So we have kind of an internal motto in EnergySingularity, which is nobody should do the same task more than 10 times. So, we will take all the findings that we have here, and there is a long backlog already, so that we actually prepare to do this hackathons with the software at any time. And so we want to shorten this process even of rotating and testing new features and so forth. So all the proposals that you have sound enormously sexy to us. So of all the teams, and we will definitely follow up with this. As a closing note, what is driving us is grid singularity, and I'm very happy that this kind of is resonating with all of you, and you joining this ecosystem. Is we tried a different path in the energy sector. So we try to build ecosystems, and once the ecosystems start to appear, we actually decentralizing ourselves, which is very tough, So one of the first times we did it was actually the Energy Web Foundation, which is a non-profit foundation, and we brought everyone together around the globe around this idea to create the smallest common denominator. And it took us a few years to build it up until it was growing very fast and it became its own body and so forth. And we actually decentralized ourselves, and it will continue. The decentralization will continue because this mission critical piece, of this market design, this cannot be run by a single company. And it needs to be a shared trust layer. And so we actually have the same goal to do with D3A. And I'm very happy that it's kind of what is happening here at the hackathon is resonating with that. So we now are at the beginning of a creation of an ecosystem. And I love to see that all the teams are seeing their own business models on top of this market design in different ways. On the Kaggle, the aggregation. It's fantastic to see this kind of different business models from each perspective, and be assured it will be our goal again to decentralize these three as well, because now as we have a chain that is scaling further and further, we will bring those exchanges more and more on chain, and the data scientists would, so to give a kind of a closing picture here, what we did at this hackathon was basically we did baby steps in getting to the model. Baby steps in terms of trying first few grid fees, flexible fees, and then on the aggregator side, the data scientists, you only had to predict kind of the right price to get the right price and cope with the flexible grid fees. Then with the Canary network, you had to predict demand and supply. In the next hackathon, trust me, you will get another variable, which is the human input. And I think then it gets really interesting. And we actually now, in the next few minutes, we're going over to the next step, which is the human input, because we want to trigger a different way of human input, and that is the Stream2 kind of teams. So in the next hackathon, I'm not exactly sure when that's going to happen, but it won't take longer than 6 months for sure. We want to combine these two streams into one. And so, yeah, thanks a lot. Big thank you from us. Regardless how the judges will give their judgment to the teams, we will follow up with each team individual. Thanks a lot.
Thanks, Ed, and thanks everybody, especially everybody taking part in all of the other sessions and discussions, and even the ones that went way off from the original topic, like in the challenge questions. I think we all learned a lot. So we'll transition now over to Stream 2, and Natalia will take over.
Yes, thank